welcome to another physics video. In this lesson, we'll be solving a question on the topic current electricity. And here's the question. Figure B 8.1 shows three resistors connected to a 12-volt battery. Calculate A, the effective resistance between X and Y, B, the current flowing in the battery, and then C, the current flowing through the 6 ohms resistor. So let's first start with the effective resistance. So we have to find the total resistance for the two resistors connected in parallel. So we use the formula R1 multiplied by R2 and then R1 multiplied by R2. So we get 12. We replace where there's R1 and then we multiply this with 6 and then divide by 12 and then plus 6. 12 multiplied by 6, you get 72. And then 12 plus 6, you get 18. 72 divided by 18, we have the resistance in parallel equal to 4 ohms. And then from this one, we can now calculate the total resistance by adding the 2 ohms plus the resistance in parallel, which will be 2 ohms, and then plus 4 ohms. 2 plus 4 will just give us 6 ohms. So 6 ohms is the resistance through this circuit. Now we can go to the second part of the question, which is asking us to calculate the current flowing in the battery. In order to calculate the current, we say current equals the voltage over the resistance. And we have the voltage as 12 volts. And we have a resistance as 6 ohms. So here the current 12 divided by 6 will just give us 2 amps. So that is the current flowing through the battery. Now from this, we can also calculate, we can now move on to the last part of the question, which is calculating the current flowing through the 6 ohms resistor. So let's keep these values first. I don't know where we can light it, but we can wrap this. The resistance is 6. And maybe we should keep this other one as well, 2 ohms. So in order to calculate the current which is flowing through the 6 ohms resistor, we have to find the voltage which is flowing through the parallel resistors here, which are the resistors connected in parallel. So we say voltage is equal to current multiplied by resistance. And in this case, we found that the total resistance for the ones connected in parallel here, it was 4. So we get the current, this current 2A, and then we multiply it with the 4 ohms. 2 multiplied by 4, we have a voltage of 8 volts. So now we have the voltage for the resistors connected in parallel. Now we can find the current. So therefore the current will be given by the voltage over the resistance. And in this case, the resistance which we will be using, it is the 6 ohms here. So we have 8 volts and then divide by 6 ohms. 8 divided by 6, you have 8 into 6, that is 1.33 amps. So this is your current, 1.33 amps. That is the current throwing through the 6 amps resistor. We have come to the end of the lesson, and I hope you enjoyed the lesson. And if you're watching me on TikTok, you can follow my page. And if you are watching me on YouTube, you can subscribe to my channel, and I'll see you in the next video.